Okay, when we're finding angles with vectors, okay, we're going to be using the scalar product. Now the scalar product, when we do A dot B, that means the magnitude of vector A times the magnitude of vector B times cos of the angle between them, cos of theta. Okay, now you can memorize that, that's good to know, but a rearrangement of that that's very useful is that cos of theta equals, so I'm going to divide by these two things, so I'm getting the magnitude, the vector A dotted with the vector B over the magnitude of vector A times the magnitude of vector B. Okay, so when you're doing angles work, you need to start with two column vectors and then you slot them into this recipe and that tells you cos of the angle. So the simplest case, like in part A, is I've got the two vectors. So I'm going to write them out again because this is the template. You need to have two column vectors written out clearly before you start doing anything. And those have to be the two directions you want the angle between. And sometimes you've got a little bit of work to do getting these. So this is the two directions. Okay, so we're going to start with some directions and then we're going to use the cos theta recipe. So the cos theta recipe I can do straight away because I've already got my directions, equals 2 minus 1, 0, dotted with 1, 4, 5. Okay, all right, so I've been talking about the dot product, the scalar product. Okay, what does that mean? Well, I'm about to show you. The way we do the scalar product of two vectors, it's called the scalar product because the answer is not a vector. You're multiplying a vector, kind of multiplying a vector by another vector, but the answer you get, although it involves multiplication, is not a vector. 2 times 1 is 2, but I don't write that in a vector of 2 bit. It's 2 times 1 is 2, and then minus 1 times 4 is minus 4, so it's 2 plus minus 4, plus, and then 0 times 5 is 0. So I multiply the x bits and the y bits and the z bits, but then I add them together. That's just the recipe for the scalar product. So I've got an answer for the scale. Well, hang on, I haven't done the whole formula. So that's going to be the top of my fraction. Okay, the bottom of my fraction is the magnitude of this vector times the magnitude of this other vector, which we've just done. The magnitude of a vector, first one is 2 squared plus minus 1 squared, which is the same as 1 squared, plus 0 squared, times the square root of, this one is 1 squared, plus 4 squared, plus 5 squared. So the top is 2 plus minus 4 plus 0, and the bottom is, this is 2 squared is 4 plus 1 squared is 5, so this is the square root of 5, and this one is 1 plus 16 plus 25, which is 17 plus 25, which is 42, so it's square root of 42. Okay, now in general, and sometimes we have to work exactly with cos theta, so sometimes you keep this in surd form, okay, but we can get away with just lobbing that onto the calculator. So there it is, calculator gives me that decimal. So cos of theta is minus 0.138. And there it is there, okay, and here it is on the calculator, but that's cos of theta, remember? Cos of theta is all of this. So I need to inverse cos that answer, and in vectors, one place in A2 work where we tend to work in degrees, not radians. So I have got my calculator in degree mode, but look critically at your answer. Does it make sense in degrees or radians? Is this a sensible number of degrees? No, because I did something wrong. Inverse cos of what answer? Let's make sure I've got that answer again. Don't know what that's doing. Inverse cos, shift cos, that answer equals 97.9 degrees. So theta equals 97.9 degrees. Now notice this negative cos means that I'm going to get an obtuse angle. Remember the cos graph looks like this. Okay, so when we go past, this is 360 here, this is 180 degrees, this is 90 degrees. When we go past 90 degrees, cos swaps from being positive to negative. And you quite often get obtuse angles in vectors. Okay, sometimes it asks you for an obtuse angle. It can't do here because sometimes it asks you for an acute angle. It can't ask us for the acute angle here because the angle between these vectors just is obtuse. Remember that the directions of the vectors matter. So if directed away from the same point, this is an obtuse angle. There's no way of getting away from that. So we've got an angle of more than 90 degrees. And that's associated with it being a negative cos. Okay, but just bear in mind, sometimes you will get questions where they ask for an acute angle, which means that we need to change this to a positive, or we need to adjust this to an angle less than 90 degrees. That is going to happen, okay, but not on this particular topic here. And this one here, I want the angle ABC. So there's a triangle. Sometimes you might need all three angles of the triangle. In this particular case, I need to draw it, is the main thing here. Remember, in order to use the cos theta recipe, I needed to set up two directions, okay? But here I've got 3 points. Points don't directly tell me directions. I need to set up some column vectors, but only a diagram will tell me which column vectors to set up. So if I draw any triangle ABC, I'm not trying to draw it accurately at all. The purpose of the triangle is for me to find the correct 2 vectors to find. So I want the angle ABC. That means the angle is at the middle point at B. So I want this angle here. What 2 vectors do I need? Well, remember, if I want this angle, the vectors have to be pointing away from the angle. Or they can both be pointing towards the angle, but I always draw them pointing away from the angle if I get any choice. So you're consistent about the way you set it up. So my 2 directions, remember for the template, we need 2 directions as column vectors. Okay, my 2 directions are going to be, this one is not AB, it's BA. So my vectors I need are BA, and the other one is this one, which is from B to C. How do I work out vector BA? Well, it's the subtraction recipe. A comes last, so it's OA minus OB, okay, which is OA minus OB. So it's that one minus that one, which is minus 2 minus 2 minus 1. Okay, we had that answer before on a previous example, but it was the other way around, so I've just made it negative. BC. BC is OC minus OB. So that's 6, 4, 8 minus 3, 5, 8, which is 6 minus 3 is 3, 4 minus 5 is minus 1, 8 minus 8 is 0, yes. Okay, so I've got 2 directions, this one and this one. So therefore my cos theta, using the cos theta recipe, I need to do minus 2, 1, dotted with 3, minus 1, 0, over the magnitude of the first one times the magnitude of the second one. Okay, this was a minus 1, wasn't it? So the magnitude of that one is 4 plus 4 plus 1, 2 squared plus 2 squared plus 1 squared. All the minuses vanish when I square. And this one here, 3 squared is 9, plus minus 1 squared is 1, plus 0 squared is 0. Okay, so I've got to do the dot product on the top. So the dot product, I'll do the minus 2 times the plus 3, which is going to be minus 6. And then I need to do the minus 2 times the minus 1, which is going to be plus 2. And then I need to do the minus 1 times the 0, which is plus 0. And on the bottom, I've got, this adds up to 9, so it's square root of 9 times the square root of 10. 9 plus 1 is 10, okay? And so therefore, the answer for cos theta is going to be this, which is minus 4 over root 9 root 10, which when I do that on the calculator, here it is, it gives me, that in third form, minus 0.4216. And it's a good idea to record that answer at this stage. But of course, what we want is the actual angle that's the cos of. So I want to know what theta is. Notice I'm expecting, because this is negative, I'm expecting an obtuse theta. So when I do inverse cos of that answer, I hope I'm in degrees, yes I am, I'm going to get 114.9 degrees. So theta is 114.9 degrees, and it's normal to give the answers in degrees to 1 decimal place, or sometimes they ask for the nearest degree. If they don't say, give at least 1 decimal place is my advice. So that's how we do our calculations leading to angles, and the one thing that I want you to do is always set up 2 column vectors as your directions before you go to the cos theta recipe, because sometimes there's just a little bit of thinking to do. We had a little bit of work to do to set those up here. That's quite common.